Ain't nothing better than simplifying radical expressions. It's one of the best things in math, so let's get started with it. In both of these scenarios, we're being asked to subtract two radical expressions. So how do we go about doing something like that? It's kind of like combining like terms if you think about it. We can't add a 5 plus a 3x together because this term doesn't have an x on it, this term does. We have to have like terms in order to combine them through addition or subtraction. Same goes with radicals. I can't just add these together. Sometimes kids will think 50 and 32 can just be subtracted, and that's just not the case. What we actually want to do is we want to simplify each one of these radicals. So let's just do a quick review on how to do that. 50 comes from two numbers being multiplied together. We're going to factor 50 into two values that multiply to make 50, but one of these two values has to be a perfect square. So right away I'm thinking, well, 25 times 2 makes 50, and 25 is a perfect square, so I think I'm doing this right. 2 needs to come down, and it's going to attach to everything like it has been the whole time. Over here, we want to say minus, bring the subtraction symbol down. Two numbers that multiply together to make 32, but remember, one of these has to be a perfect square. Well, 32 cut in half makes 16. 16 times 2 makes 32. And guess what? 16, that's a perfect square. So we're doing great. And see how we have two root 2's? That's important. We want those to match up because that's kind of like having an x attached. That allows them to be added or subtracted, meaning they're like terms now. Okay, so square root of 25. That's just 5. I'm going to put it in parentheses because we have the 2 to be brought down. Root 2 cannot simplify at all, so it remains root 2. Minus square root of 16, that's just 4, and then we have the root 2 attached. So if you think about this, that's going to turn into 10 root 2, and we're subtracting 4 root 2. I tell my students this is no different than 10x minus 4x. When we do that, the x's don't change at all. We just say, what's 10 minus 4? 6, and then we attach the x to it. So same idea here. We're just going to be saying 10 minus 4, but remember both terms are root 2's. So instead of x, let's just change that to 10 minus 4 is 6, root 2. And this would be simplified from that expression. Let's look at the second one. Same idea. We're going to say 3 comes down, but I got to split 24 into two numbers, one of which needs to be a perfect square. Earlier today, I did this problem in class, and a kid shouted out, 12 times 2. Heck yeah, you know how to multiply two numbers together to make 24, but gosh darn it, 12 and 2, neither of them are perfect squares. So I need something that's a perfect square. Well, that's going to be 4 times 6. 4, bring the 3 down. 4 as a radical is going to give me 2. 2 times itself makes 4. Put parentheses around it, bring the 3 down. Root 6 doesn't simplify at all, so keep it attached. Now we're going to subtract square root of 54. But we got to split 54 into two numbers, one of which has to be a perfect square. So I'm going to say minus square root of 9 times the square root of 6. 9 times 6 makes 54, but the square root of 9 comes out to a nice, neat 3. Root 6 doesn't simplify, so you just bring it down along for the ride. We're almost done here. We just got to do 3 times 2. That makes 6 root 6 minus 3 root 6. And because these radicals match, these are like terms. We can combine them through subtraction. What's 6 minus 3? 3. What's the square root of 6? And the square root of 6 just gets brought down and attached. So we have our final answer of 3 root 6. Hopefully this makes sense. Study hard. You're working hard in your algebra classes. You got this. Good luck on your upcoming test.